what we're building is the MSA diaphragm, and what this is it sits between the propellant stage of the rocket and the Orion capsule. This is a very important barrier that we need to have on this rocket to keep the hazardous gases coming off of the propellant stage from getting up into the Orion capsule. The diaphragm is 100% composite structure. That is a fabric that is a carbon fiber fabric with epoxy. And when this is all put together, it makes for a very strong, very lightweight structure, and that's key for spaceflight.
Well, this is the flight diaphragm that will actually fly in the first Orion EFT-1 flight test. And with any new structure, we have to proof test it to make sure it can withstand the structural capability of the flight loads, which also includes thermal loads, inertial loads.
So the main design drivers for the diaphragm were to handle launch loads, which can be up to 5 Gs, and also a pressure difference between the propellant stage and the Orion capsule. And so that pressure difference is what we are testing here today. When you're dealing with composites, it's a very process-sensitive material to use. And so every time you use composites, you really need to get acceptance from the engineering community about how to fabricate and to test the composites that you're using. So that's been the most challenging thing, I think, is to really develop a roadmap that the engineering community can get buy-in to, and to prove out that the design that we're making and the analysis that we're showing is good can be substantiated by test.
We actually installed 4 triaxial strain gauges, so that measures any strain that the article sees, and that way the test requester can watch the data real time as we're applying the load and make sure that it's not exceeding any strain that he kind of predicted.
There is a benchmark in using composites in this way. It's the largest structure made entirely of composite that NASA has endorsed to be put on a spacecraft. And working inter-center to develop that and to make that a reality is a key milestone to how we're going to be doing rockets in the future. I think a lot of people are going to be looking back on this partnership for future development and future flights.